Alright, Bismillahirrahmanirrahim. Assalamualaikum and very good morning to everyone. So we'll be talking about the metal processing today. Specifically, we'll be discussing about the fundamental of metal casting. Alright, so when we talk about metal casting, these are the learning outcomes of this specific subchapter. First, you are expected to define principle of metal casting, which the casting processes at the end of the chapter. Secondly, you should be able to understand the basic of solidification in metals and and explain briefly the elements of gating system. Gating system is the system to control in when we pour your molten metal into the mold. Right, next is students should be able to explain briefly on factors that affecting fluidity of the molten metals. And finally, students should be able to summarize the possible effect that could happen during solidification. As for introduction, casting process basically involves number one, pouring of molten metal into a mold pattern after the part to be manufactured. And after we pour the molten metals into the mold, we allow them to solidify. And following that, we remove the part of the mold, which is finally we'll get the products. Some important consideration in casting operations are as follows. Number one, the flow of the molten metal into the mold cavity. Secondly, the solidification and cooling of the metal in the mold. And third, the type of the mold materials that may influence the whole process and also the final product. So this chapter will be describing the relationship among the many factors involving in casting. There are a few types of mold. If you can see on the left of the screen, there is mold here, and this is the basic overview of open mold. And this is the molten metals, and this is the mold cavity. Cavity is kind of a space within the mold. And this is the mold materials, and this is a flask like as the insulator. All right, next to it, you can see there is another figure showing a closed mold. If you see the open mold, it's like the cavity is open. It's like the whole shape of the mold is open to be filled in with the molten metal. But for closed mold, it works the other way around, in which that we have the pouring cup here, and then the molten metal will be filled in or poured through this channel, and then this is the main cavity. It's like the product is quite different. And the mold material is surrounding the main cavity, and we also have flasks. All right, flow of melt in the mold. We know when you know that when you have the molten metals, which the raw materials of metal are already heated to certain temperature, and it turns into molten metals. So these molten metals is the main substance, main materials to be poured into the mold. Okay, so we are considering the flow of the melt in the mold. So melt, the molten metal itself, is poured into the mold cavity through a pouring cup. Okay, so the melt the melt flows through the gating system, which consists of sprue, runners, and gate. And each of these elements are having different functionalities. What is sprue? Sprue is a vertical channel through which melt flows downward. It's going down, yeah? It's like a channel. Allow the pore of the metal, the molten metals, to go through. Number two, we have runners. What is runners? Runners are channels that carry melt from sprue into cavity. Cavity is the real spaces of the mold materials. Gate, part of the runner through which melt enters cavity. And then we have risers. If you see the figures, risers are the reservoir that supply melt during solidification. Solidification is the process from the molten metals, which is in liquid form, to turns into solid materials. So there is a pouring cup here, risers, sprue, gating system, and this is the mold cavity. And this is the core, and some other part like drag, core prints, and cope. Cope is on the top of it. Yep. Drag is the down. Cope and drag. Okay, up and down. So the element of mold, what is so important to know about the element of mold? Because the final products that we'll be getting from the casting process is depending on the element of mold that we are using. So if you have cope, this is the cope. Down here we have drag. It's like a top and bottom, and you insert the pattern into the spaces. Okay, this is drag. Okay. And then the mold should contain two parts. This is the thing that I see just now, the cope, which is on the top, and the drag from the bottom. And we are designing the mold or the whole system to be in this way. Okay, so this is like the pattern that we are going to have within the mold. Okay, so the pattern is placed in the mold, and the parting line, which is this is the parting line, yeah. Sorry, this one. Yep. The parting line between cope and drag allows for the mold to be open. It's like a separation. It's in the line is actually a door, so that it will be open. To be open and allows for the mold to be open and the pattern to be removed once the impression has been made. And with that, we can see that there is another things that we should consider is that the pattern impression with the core in place. Okay, this is the part impression. This is a chaplet to ensure the tighten of the system. The core is placed in the mold after removal of the pattern, and this is what it became after. So this is we have the gating system for the casting. Okay, this is a pouring basin. First and foremost that we are setting the pattern, right? And then after we will be putting some setting on the pouring basin, open risers, so that all are connected to each other. Okay, so the reason of gating system is to facilitate the flow of the molten materials into the mold cavity. Yeah. So this is the thing that we can skip. Okay, element of gating system. Gating system, we talked about it just now. So there are a few elements that I actually mentioned at the beginning. Number one is pouring basin. So this pouring basin, this is where that the molten metal employed. The molten metal is applied to manufacture the part enters the mold. The pouring basin should have a projection with a radius around it to reduce turbulence. Okay. Down sprue. Okay, we have sprue base and down sprue. Okay, from the pouring basin, the molten metal for the casting travel through the down sprue, and this should be tapered so its cross sections reduce as it goes downward. Okay, sprue base. The down sprue ends at the sprue base, and it is here the casting inner cavity begins. I think when we see the photo or any diagram, it will be easier for you. You can just always go backward or forward after to see the figure. Okay, ingate and coke area. Once the sprue base of the molten materials must pass through the ingate indoor to enter the inner area of the mold. And the ingate is very important for regulation during the metal casting operation. Other than that, we have runners. Runners are passage. It's like you know, the path that distributes the liquid metal to differentiate areas inside the mold. The main cavity, we have another main cavity. The impression of the actual part to be cast is often referred as the main cavity. This is the main cavity, the meaning of the main cavity. Vents. Vents help to assist in the escape of gases that are expelled from the molten metal during the solidification phases of the metal casting process. You know that when you involve turning the molten metal into solid materials, and of course all the gases that entrap within the liquid will be venting out. Okay, we have risers. Risers are again a reservoir of molten materials. They fit in these materials to section of the mold to compensate for shrinkage as the casting solidified. Okay, there are different classifications for risers. We have top risers, side risers, blind risers, and open risers. Okay. All right. This is the thing about the core of this subtopic, which is the solidification of the metals. So after the molten metal is poured into a mold, a series of events take place during the solidification of the metal, and it is cooling to ambient temperature. And these events, although the events of towards the solidification, greatly influenced by the shape, the size, the uniformity, and chemical composition of the grains formed throughout the casting, which in turn influence its overall preparation. So in this case, if we would like to discuss size, shape, uniformity, and chemical composition of the grain. I think we have discussed this before in the class in another subject. Because grain is the microstructure that are forming the whole system of the materials. Okay, so for pure metals, okay, pure metals has a clearly defined melting temperature and melting or freezing points because it is pure metal. There is no other element within the system. It's like when it is copper, it's just copper inside. There is no chromium or whatever, any other elements. Okay, so it's solidified at a constant temperature. It means that the temperature that we are setting for the pure metals, we already know. Okay, nothing much will be imparted to see some differences, but you know, it's like very clear that we have certain melting temperature. Okay, so if you see the figure down there, this is the figure of temperature versus time. Temperature are increasing and time also increasing. From down to top for on the y-axis for temperature, x-axis is the time. Okay. So this is the starting point. If you see solidification, and of course, when you have the molten metals, the temperature is even higher. So the cooling of the liquid starts here. It goes down to a point called A. This point, we call it as solidification begins, where the solidification will start to take into event. And this is a line of the solidification temperature. If you see, this is happening at the liquid phase. And then when the temperature approaching this line, the liquid just now will be having another phase, which is solid materials, from this point to another point, which is B point. So we're having more time. It's like time is running until point B, and at point B, it says here the solidification ends. Okay, so from B, it is cooling down to become a real solid. Okay, so this is how the temperature and time parameter are playing their roles to show and explain to you about the solidification of pure metals. This is some explanation from the referring to this diagram. So after the temperature of the molten metal drops to its freezing point, its temperature remains constant. As I said, it is remain constant from A to B. So during this event, at the mole wall, which are the ambient temperature, or at least are much cooler than the molten metal, which is the molten metal is high, much the temperature is higher. The metal cools rapidly and produce a solidified skin. Okay. Okay. When you talk about solidification, this is like a must remember figure. Right. This is about the dendritic growth, which is explaining what is happening on the microstructure of your metals. Okay, number one. So when you have the molten liquid, this is like you are having small nuclei act as centers of crystal growth. This is like a center for crystal growth, all the small nuclei. And when the temperature is going down, we can see that they are forming dendrites, which these dendrites continue to grow. So it grows in a similar manner to seed, forming a seed crystal. Okay, so this is number 3. Sorry, I missed the point number 2. Small dendrites begin to develop from nuclei. So from this small nuclei, it will begin to develop, becoming a small dendrites, and the dendrites continue to grow at stage 3. Meanwhile, at stage 4, dendrites grow, the spaces between them fill in. So, you know, like when you are combining all the dendrites, which all the dendrites we have more dendrites, and you see that there are some spaces in between the dendrites. So the spaces is actually coming to will be forming another space, because you are combining some spaces between spaces. Okay, so as the explanation about the number 3, at its growth, branches called dendrites grow in tree-like structure. So the dendrites are in the form of tree-like structure, and then the dendrite spread out and meet other dendrites and a crystal forms. Okay. Grain boundary are produced by impurities bonded together. So these are the grain boundaries. These are we call it GB, grain boundary. So this grain boundary are allowed within the structure, and this is the phase that we call solidification is complete, and we can see that little evidence of the dendrite structure remains. There are some more, just like small part of it remain there. Okay, this is like fully solidified. And talking about the real process, how metals solidify. These metals actually is very interesting. If you see, this is the assuming that now we are assuming that this figure are showing the liquid metal is poured into the mold, and it solidifies in the following step. Okay, if you see the figure A, a thin layer cools and solidifies where the metal touches the mold surfaces. Okay, it touches the mold surfaces. In B, heat is sucked out. So you know, like the molten metal definitely is very hot, and all the heat is sucked out of the metal anywhere. It is touching the mold, and crystal dendrites form along the surface layer. So dendrites are started forming from the first layer that it is forming. C, as the heat continues to leave via the metal or mold interface, the dendrites grow. So it grows even more. And then at D, the next step, metal in the center finally cools. Okay, metals in the center finally cools enough to start start to crystallize. Okay, small seed crystal form. Okay, and finally, this stick crystal multiply and grow until the casting is solid. So now it is fully formed as solid. So now we have the complete solidified metal. All right. Those are the things that we've been talking so far, which is the solidification of materials, specifically metal, started from how the heat is going down to make the molten metal solidified. All right.